Hello, and welcome back to Algebra 2 again. Hopefully you had everything go okay yesterday. Yesterday's notes went a little bit longer than I wanted them to. I'm hopefully able to go faster today, so I will stop talking and get right into things. So yesterday we looked at the inverses of quadratics and their graphs. Today we're going to be looking at the inverses of cubics and their graphs. Okay, so I already have some stuff set up. So if you kind of actually have a little bit of review from yesterday. So if you remember yesterday, we started with the equation y equals x squared, and we found its inverse. Remember, to find the inverse, you swap the x and y's like you see right here, and then you solve for y. So that involves using the square roots like that. And then, of course, since we're in an equation setting, you put that plus or minus in front. So you have y equals plus or minus the square root of x. To graph plus or minus the square root of x, you have to split this into two separate equations. You have to split it into y equals the positive square root of x and y equals the negative square root of x. Okay, now I only made one table right here just for the positive square root of x, but you could also do the same table for the negative square root of x right here if you wanted to, and it would look something like this. I'll just do that here real quick. It would be same numbers, but then it'd be 0, it'd be -1, -2, -3, and -4. Because when you square root, like for example 16, you get 4, but then there's that negative in front there that would make it a -4. And so then when we graph both of these tables here and here, all right, you can see them right here. Okay, I've graphed them for you, and you can see that what does it create? It creates that same kind of parabola shape that we're used to, except it's kind of transformed a little bit. All right, and it's I also took the liberty of graphing in y equals x squared, our normal parabola here, and then there's its inverse right here, the y equals the square plus or minus the square root of x. And you can see that it's a reflection, it's an exact reflection over this line here, which is the line y equals x. Ooh, I did a lot of dots, and now I have to like undo all those. Okay. Okay, so you can see that kind of, graphically speaking. So then we'll have a similar relationship for today. Today we're going to be looking at y equals x cubed and finding its inverse. So same way we did before, we'll swap the x's and y's, and then we'll solve for y. So to get the y by itself right here, we'll need to cube root both sides. And that involves like the square root symbol, but you put a little 3 there instead. So we get y equals the cube root of x. Now a cube root, right, we don't need to put that plus or minus in front. Okay, we can just leave it as the cube root. Remember, any odd-powered roots, you don't need the plus or minus. It's only the even roots that you need to put that plus or minus in front. So we'll go over here to make our table. And again, we'll pick some values for x. Now yesterday, right, we were limited to only positive numbers for our x values, because when you square root a positive number, right, you get a positive number. But when you square root a negative number, you get an imaginary number, and we couldn't graph that. Here, we can cube root any number, positive or negative, and it'll end up with a positive or negative answer, respectively. So we'll put in whatever numbers we want here. So I'm going to actually put it 0, but I'm going to put 0 in the center, so that way I can use some negative numbers over here and some positive numbers over here. So what will be some good negative numbers to pick? Well, -1, for example, because we can cube root the -1. Another easy cube root to do, -8. Okay, and of course on the positive side, we can do +1 and +8 as well. Okay, so just like yesterday where we kind of like were using that 0, 1, 4, 9, 16, okay, to help us with our x values, our x values here will be something like -8, -1, 0, 1, and 8. Okay, those are all perfect cubes. And of course you can keep going if you wanted to. You could do like 27, which is 3 cubed, and 64, which is 4 cubed. But again, those numbers get kind of big, so we kind of keep them to round these that I've got right here. Excuse me. So what is the cube root of 8? Well, you want to think about, actually, let's do the positive ones first. They're a bit easier. So what's the cube root of 0? In other words, what times what times what? What multiplied with itself 3 times gives you 0? And of course the answer is 0, right? And then what multiplied with itself what multiplies with itself 3 times to give you 1? Well, it's 1 times 1 times 1, so answer is 1 here for the cube root of 1. Cube root of 8, what times itself 3 times gives you 8? Well, hopefully you answered 2. Okay? Remember, when I ask questions, feel free to pause the video after I ask a question and answer it for yourself before resuming and hearing my answer. It's a good way to help you learn and to practice, rather than just kind of like, it's more an active way to engage with the lesson rather than just kind of passively just sitting there and letting my, you know, droning voice wash over you, okay? So try and engage actively, and that's one suggestion I have for you. All right, with -1 then, what number multiplied with itself 3 times gives you -1? Well, it's -1. And then what number times itself 3 times gives you -8? And that would be -2. Okay, and so there's our points. And so I'll go over here and graph those. I'll count by 2's here on the x-axis. So 2, 4, 6, 8. Like that. And I'll count by 1's on the y-axis. Oops, I guess I should count 2 this way. 2, 4, 6, and 8. Okay, and we'll plot our points. Now, if you remember what a cubic looks like, a cubic looks something like this, right? Well, maybe I'll be very careful here. Okay, so that's what our cubic's going to look like that. Okay, that's y equals x cubed. But now in red, I'll do this right here. Okay. So, -8, -2, -1, -1, 1, 1, and then 2, or 8, 2, 8, 2. So we're going to look something like this. Whoops. And again, you can see that reflection, right? You can see that line of reflection. Again, if I kind of draw in the line y equals x here, it's going to look something more like this. Okay, there's that line y equals x, and you can see that reflection over the line y equals x that inverse creates for us. Okay, again, in red, that is our inverse. There, that's a cubic, the cube root of x. All right. Let's try practice finding some inverses here. So, for example, we want to find the inverse of this. So we'll say y equals, oops, don't need to write that twice. And we'll swap the x and y's. Okay, and in this case, we want to solve for y. So I'm going to get rid of the 0.5 first. Now, it's 0.5 times y cubed, so you could divide both sides by 0.5. Remember, that's really like a 1 in front of the x there. So 1 divided by 0.5 ends up being 2. Okay, another way to think about this is to get rid of 0.5. That's the same as 1/2, so you could also double both sides if you wanted to. That's another option, but we'll just do the divide by 2. Okay, those cancel. We have y cubed. And so then, oops, 2x. And we cube root both sides. And we get y equals the cube root of 2x. And voila, there's our inverse. All right, let's try this next one. Okay, find the inverse of this. So again, we will swap our x and y's. Okay, in this case, what do we want to do to solve for y? Our next step would be what? Okay, yeah, we're going to add 9 to both sides here. So you get x plus 9 equals y to the third. Okay, and then cube root both sides. So we get y equals the cube root of x plus 9. Remember that plus 9 is inside the parenthesis there. And there it is. Easy peasy. Now, for graphing. All right, once again, I've summarized excuse me, all of the graphing transformations for which you need to be responsible. Okay, so again, taking our parent function y equals x cubed, which is what we graphed, you know, right up here. Okay, in red, this right here, right? Okay, that's y equals x cubed. Or sorry, cube root of x, I mean. Oops, and we're drafting transformations of not x cubed. This is for cube root of x. That's a mistake. There we go. And this is not x cubed. It should be cube root of x. There we go. Like that. Okay, much better. Fixed it. So anyway, you can see transformations, right? So again, very typical stuff, right? There's our a, okay? If a is greater than 0, if a absolute value of a is greater than 0, then we have a vertical stretch. If a is between 0 and 1, then we have a vertical shrink. And if a is less than 0, then we know that's a reflection over the x-axis, along with a stretch or a shrink, you know, if a is, you know, not 1, or -1, I mean. Okay? With minus h, right there, that's a shift right if h is positive. So if we are subtracting a positive number here, then that means we are shifting right h units. And if we subtract a negative number here, well, remember that's really adding a positive. So if you see plus h, or if you see, you know, minus negative h, that's a shift left. that many H units there. Okay? And finally over here, K. If we are adding K, if we add a positive K, it means we're going to go up that many units. Our graph will go up that many units. And if we're going to shift down, that means K will be less than 0. Okay, if I go back up to my table here, what's the thing that we're going to be transforming? Well, just like we had that special kind of, starting point here with the 0, 0 when we did square root of x, okay, that was our special starting point. Here as well, 0, 0, the center of our graph will be the transformation that we do first for those, like shifting left, right, up, and down kind of stuff. So this is going to find the center of our graph. So right now, if we look at this one, okay, can you go ahead and just identify the transformations? What are they? Pause the video and do it. Okay, hopefully you said that we were going to be shifting right 3, thanks to the -3 here, and we're going to be shifting up 6, thanks to that. So our new table is going to be not 0, 0 in the center, we're shifting right 3. Okay, so normally this point would be a 0, right? And then we're going to go up 6, so then the y-coordinate will be 6. So that's like our 0. And then we also have like the 1, remember? And then we also had 8 over here. And then here we had -1, if you remember. And here we had -8. Okay, and again, that's just from what we did up here. We were picking those easy, perfect cubes. Remember from our original table there when we were graphing the cube root x. So now when I go to graph this and create my table, 1 was my original point. Remember that we shifted right 3. So what's 1 shifted? What is this 1 here shifted right 3? Well, that's going to be 4, right? And this 8 is also going to get shifted right 3. So we'll be at 11. The -1 will get shifted right 3. And so that's going to be at 2. And then the -8 is going to be shifted right 3. And so that'll be at -5. Now at this point, you can, again, plug each one of these x values in to the function and evaluate to find the y values. Or you can use the table on your graphing calculator and just find these missing y values using your table. Okay. We can also understand, though, that just like these x values were all shifted right 3, the y values that go down here, they're all going to be shifted up 6. So if you go back to our original y values here, which were -2, -1, 0, 1, and 2, this trick also works for what we did yesterday, too. Okay, you can see here that all like this y value of 0 was shifted up 6 to 6, and that's from the up 6 transformation there. So this y value of 1 would also be shifted up 6, so this should be 7. This y value of 2 should also be shifted up 6 to be 8. Oops, I should do this first. There we go. Okay, this y value of -1 will be shifted up 6 to 5, and this y value of -2 will be shifted up 6 to 4. And so there's our new graph. Okay, and so we can plot that. You can see here, since I have all positive y values, I'm not going to worry about graphing too much on below the x-axis here. So I'll just kind of do something like this. Okay, and so we'll plot our points. And again, I'll just count by 2's here. So 2, 4, 6, 8, 10. And then -2 is all I really need. Oh, no, -4, -5. And then we're going to have, let's see here, 2, 4, 6, 8. I'll do this one in blue just so it stands out against the background here. So -5, 4. So -5, 4 is this point right here. And then 2, 5 right there. And then 3, 6 right there. And then 4, 7 right there. And then 11, 8. So 11 would be like over here. And then 8 would be up there. And so we can kind of... And there's our cube root. Okay. You can also go to your graphing calculator's table and check out these numbers as well in the table. All right, let's do one more here. Okay, so what are the transformations here? Well, so pause and do it. So vertical stretch by 2. Okay, that's where this comes from. Then we're going to go right 3. And then we're going to go up 5. Okay, so when I go to make my chart, again, I'll put 0, 0 here in the center. Remember, it's 0, 0, but the zeros were shifted right 3, so now I'm at 3, and this y-coordinate here was shifted up 5. Oops, actually, I'm going to have to hold off on that. I'm just going to use the table, my graphing calculator. So 0, and then we had 1, negative 1 here, right? 1 goes here, 8 goes here, negative 8 goes here. All right, so these are all going to be shifted right 3. So, excuse me. So right 3 from negative 8 is negative 5, 2 from negative 1, 4 from 1, and 11 from 8. Okay, and then you can go to your graphing calculator and do this. So 2, 3 plus 5. Okay, so turn it on. Y equals 2. And now to do cube root in your graphing calculator, you have to press the math button and then arrow down, and there's your cube root right there. Hit enter. So yeah, x. Let's see here. Whoop. Let me go back up to this. X. Crikey. X minus 3. And then arrow outside of your parentheses, or arrow outside of your cube root, or make sure you close parentheses if you have the older calculators. And we can go to our table. Okay, and there we can see our answers. So 11 is 9, then 7, 5, 3, and then 1. Okay, so you can see on the table there all the different values we need. I'll go back to my notes. So 9, 7, 5, 3, and 1. And then you can plot those points. I won't bother doing that just to cut the video here. All right, so I'll put the homework on the board, on the Schoology. Let me know if you have any questions. Thanks, guys.